Hey, welcome back to the Build Show. Steve Basic Architect here. Down at one of my favorite houses here. We're down at Hilltop, although we're not going to see the outside of it today because we're totally inside here. Brought along my good friend Chris Smith. Chris is with Zehender America, and Zehender makes ventilation systems. But before we even talk about that ventilation system, let's talk about some general concepts, Chris, right? I mean, we've always heard, oh, a house has got to breathe,
Yeah.
right? I mean, if I had a penny for every time I had somebody say, oh, you don't want to build too tight, you want it to breathe. That's a load of crap, Build Show. A load of crap, all right? We don't want to build the house to breathe. We want to build it as tight as we possibly can. If I could get it hermetically sealed with airlock doors, I would build that house. And then I would rely on Zehender to allow my house to breathe, right? So talk us through a little bit in general about exactly what this system is, Chris.
Yeah, it's basically an air exchange system. So when you detail the envelope the way you've put all those air sealing details on all the junctions. This house isn't going to breathe, not very much. And so we now mechanically need to introduce outdoor air, and we need to exhaust the stale air. So we have a cabinet. It's got two separate fans in. One's a supply fan, one's an exhaust fan. We have a heat exchanger in the middle, in this case an enthalpy exchanger, and we're going to pass the two air streams through that exchanger, and we're going to change the air in this house, but we're going to respect the heating and cooling bill, and we're going to provide a really clean, healthy environment. We're filtering everything that comes in from outside, so in the end they get better than outdoor air quality inside their house.
So just to reiterate all of that, it's basically, I'll call it a four-pipe system. So we have a pipe in, a pipe out, and that brings that outside air in and exhausts it from the system. And then these are, although there are a bunch of little pipes, we have a series of exhaust and a series of supply. So that's what I'm calling the other two pipes, if you will. They're just grouped together as singular pipes. So we have that air comes in, it gets filtered, which is a good thing, right? For all of you that say our houses should breathe, I ask you, how does that air get filtered? Oh, through the edge of the dirty carpet, all through those nooks and crannies, through the fiberglass insulation, all those great filters that we build into our building assemblies, if you go that route. If you go this route, it comes through a MERV 15 filter, right? And then gets exhausted. And as Chris said, there's no energy penalty because the purpose of the enthalpy wheel, that's to strip the energy off the exhausting air that I've bought and paid for, and then I put it on the incoming airstream.
Sure.
So basically, I take those dollars or pennies, however it's measured in this case, off of that exhausting air, and I dump it on that supply air system, and I put it in. Now, Chris, talk to me a little bit about, this is a great concept, but have you ever had I'll give you a few anecdotal stories, but have you ever had any stories about people talking about how great their houses are that have these systems in? I'm sure you hear it all the time.
Yeah, I mean, I got into this business. I did design build for a number of years. I started having some clients who were living in sick houses, and through the whatever treatments they were getting, they were learning about how they had to control their indoor environment. And so we learned about this system, we learned about its role, how the air exchange is better than just, a lot of people filter air. They just run the same air over a filter over and over again inside the house. And yeah, you can knock down some particulates, but you're not really changing the quality of the air. So with this, we started seeing people getting better. It was not attributed solely to this, but as part of a regiment of recovery. That was my initial introduction, and seeing people's lives change that way. And of course, then we get into the passive house movement or the high performance or net zero home movement. And so you got these high performing building envelopes. Well, now it's just a natural part of that process too.
Right. So there's going to be people on the video too that say, oh, I don't need a ventilation system, that costs extra money and it's not worth it. Well, one thing, the code's starting to recognize it. Systems like this are going to become a requirement in all of our houses. So you might as well start getting prepared for that. Secondly, you guys have always heard me say good things cost money. You want a good, healthy house, you got to spend a little bit of money to get there. How much is your health worth, right? The other thing that I wanted to add, I have, I don't know, probably a couple dozen of these installed in passive houses and just really good energy efficient houses. But the thing that I find very common with all the clients is, one, they never want to leave their house. They always say it's the best environment that they know and that they've ever been in. And they want to stay inside there because it's not only about the air quality, it's the temperature, the humidity, all of that stuff gets controlled. And if you heard me talk about control layers, the whole reason we build a house is to gain control, because we don't want to live outside. I don't want to sleep outside. I don't want to eat outside. I don't want to, watch TV outside. I do that stuff inside. So I want the perfect climate for that. And this helps me get that perfect climate. The other thing that a lot of clients say is that they've never slept better than they sleep in a house that has, a good ventilation system and where the air quality is, at a highest. And I actually have one client, they have two houses that I did a vacation house for, and they just talk about how they always want to go to the vacation house because the air quality and the health of that environment is so noticeably different that, they can speak to dreaming better, sleeping better, just feeling better. And, they're highly athletic people, and they absolutely love coming to their cabin up in the woods. So I think it'd be a good idea. Let's, we got a quick overview of the system here. We are going to do a follow-up video to this where we talk about exactly what's happening here with all of these things specifically. But why don't we just jump upstairs and we can just do a general kind of knowledge of what the ports look like, what happens in a bathroom. The other side note for builders out there is that this system replaces all the bath fans in the house, right?
That's right.
Because those bath fans, or what would have been a bath fan, simply gets exchanged for one of these hoses.
Right.
So let's jump upstairs. We'll see you up there. All right. So we're up here in the owner's suite. This is their bedroom. And if you notice on the wall there, we have one of the supply registers. So this is delivering to the bedroom, right? But I also noticed we have one across the room there, Chris. Why is there some type of strategy as to why we have two in the room?
Yeah, we use a small tube system to deliver the air, and that kind of allows us to manage airflow and predict the amount of airflow that goes to each space.
Let's give a little bit more credit, because I know there's more to that tube than you're leading on. It's a 3-inch tube, right? Yeah. So it can fit in any 2x4 wall. Exactly. Can get snaked through. Yeah. The radius is extremely tight. Like you can bend it on itself.
Yeah. Yep, stays pretty smooth as you do that. So, minimal restriction of airflow for the bends that you get.
And these aren't running at very high volume either, right?
It's not. You have to get your hand right up against it to actually feel it. Right. The amount of air that's coming out there is nothing like a heating and cooling system. Right. We're not carrying BTUs, we're just carrying fresh air. So, but yeah, these boxes have a limited number of tubes that we can attach to them. So we wanted, this is the master suite, as you said, or owner's suite. So we wanted, 36 CFM of fresh air coming into this room all the time.
And how do we get that 36 CFM? How do we get there?
There's been studies that kind of, there's a combination of things. You go to like the ASHRAE standard, and you can learn, based on the square footage and the number of occupants, you kind of come up with a calculation for the airflow. But there have been studies just to show kind of just in general, how many CFM of outdoor air does one person kind of thrive with? And the 15 to 18 CFM range per person is pretty good. So we've just kind of said, in an owner's suite, typically you probably expect to have two people there. We're gonna get somewhere in the neighborhood of 30, 36 CFM. So in order to do that with our tube system, we've just used two boxes. We got one tube to one, two tubes to the other, and we get what we need.
Gotcha. Yeah. And then for exhaust, we can go down the hall here, because the exhaust system, here we have the exhaust system in the master bath, and it's, kind of, I say centrally located, but intelligently located in that We have the toilet there, the shower here. So we have a mixture of odor control and moisture control, right? And the cool thing about these is they're adjustable. So you can pretty much dial in that diffuser as to how much it takes out of this room, right?
Right.
And the second thing that it does, if we can come around a corner here, I mean, it's not a whole lot of magic, but we have a switch here. Now, what is this switch doing for me?
Basically, that's just a momentary contact switch. If someone's using the toilet or taking a shower, punch that, it gives a signal to the ERV down in the basement. And the ERV for a preset time is going to kick the system up into high speed. So that'll go from sucking in, say, 36 CFM to sucking in something like 54 CFM, something like that.
So it brings it into that range of your typical bath fan.
Yeah.
Right.
And, the thing is about the topic of intermittent versus continuous exhaust, for 30 minutes, maybe you think, 50 CFM, I'd rather have 100. The difference, most people haven't experienced what it's like to be in a place with continuous exhaust, and having 24 or 36 CFM of continuous exhaust 24/7 actually does a much better job than those little quick boosts.
Right.
So this helps, gets the steam off the mirror real quick, but other than that, the system's maintaining the room right where you want it all the time.
I gotcha. We're going to jump back to the studio, but before we go, one other thing came to mind as I'm standing in front of this operable window. One of the interesting things, Chris, is when we sit down at initial design, I always get from homeowners, no, Steve, you don't understand. We really like opening our windows and we love to have that air coming in from the outside, and they call it fresh air. First of all, I say, how do you know it's fresh, right? Just because it's coming in from the outside doesn't mean it's fresh. But the flip side is actually true. After we build these houses and people live in them for a while, I find that most clients sit there and tell me, we should have just put in more fixed windows because we never open the window. Because the climate and control in here is so true that there's no desire. It's not even a need. There's just no desire to try and bring that air and try and mess with such a good system.
And that sounds counterintuitive because it sounds like you're cooping yourself up in your house, but when you get the system running, delivering fresh air all the time, you don't feel that way at all.
Yeah, and I always explain it, when I'm lecturing and stuff on the system, I said, think of your own body, right? We have dedicated inputs, outputs. We have dedicated filtration systems. Our houses should act the same way, right? We shouldn't just let air come in and out willy-nilly. We need to figure out where it's coming in, treat it, and then send the bad air out. Anyways, let's jump back to the studio. I thank you, my friend, for joining me out here, giving us some insight on Zehender and what we're trying to do out here. But we'll jump back to the studio and we'll talk a little bit more about this. I'll see you back there. Hey, everybody. Welcome back to the studio. Hopefully you enjoyed that little tour out there with Chris Smith. Chris is a longtime friend working at Zehender. I've done a bunch of projects with him. He's taught me a lot about ventilation and their systems. Hopefully you enjoyed that little tour around there. I have even some further information that I got from Zehender that we can go through here. Of course, we got our big friend, Big Red. He's going to dive right in and help us disseminate some of this information. But I wanted to stress one thing, the importance of teamwork and collaboration. Zehender's a great company. They build a great piece of equipment. They do energy efficient and high performance housing, a great service by distributing and educating and assisting in the installation and commissioning of their products. So they're just a really good teammate. And, it's one thing to sit here and say, oh, well, we can design a really good house and hypothetically we can come up with a bunch of good ideas. But the reality is the number one thing we need is a really great team. So, Aero Building out there, and then we get Chris Smith from Zehender coming out and helping us out and straightening things out, and the HVAC guys out there, just one hell of a team. And the people that win are our clients, right? That's who we're in it for. So anyways, let's grab Big spreadsheet. All right. So we don't have a drawing today. I actually printed out part of the sheet that we received from Zehender. So this is some of the information that they're providing. But before we get into that, I want to just talk to you about a couple things. Remember when we were out there, we talked about, and I'm going to reiterate a couple things, you know, the simple house and the red line test, right? You're either inside or you're outside, right? There is no gray area. You're in or you're out. And our goal is always to develop as airtight a home as possible. And if you were concerned about what that number or questioning what that number is here, Jake hit 0.57, and that's ACH 50 pascals, right? And that 0.57, just so you know, it is less than the 0.60, which is passive house. So we met the passive house standard with that. And the other thing to remember is that, you know, Jake, we've certainly had better numbers, but you got to remember on that Hilltop Aero project, probably about 70% of the house is suspended above the ground. So we have that whole added layer of surface area that in most cases would usually be a basement against the ground, which really doesn't leak that, you know, any air, if any. So it becomes a little bit more of a challenge when you take that building and just kind of throw it out there in the air. But anyways, 0.57, hell of a job, Jake and Aero Building and the framers and everybody involved. Remember, inside versus outside. If I had my way, I'd hermetically seal every house here. And in doing so, we want to exchange air through the system. I drew arrows both ways, but it's basically you want to exhaust bad stuff and you want to intake good stuff, right? So we want the good stuff coming in and we want the bad stuff going out so that we can maintain this really nice cycle of comforting air inside. I'm always hesitant to say fresh air because we can't guarantee that it's fresh. But anyways, good air coming in, bad air going out. As you saw in the video, the enthalpy wheel there makes sure that our dollars spent on energy do not get wasted and get tossed out with the bad air, that they get exchanged and it gets dropped on the good air coming in and tempers it as the bad air goes out. So anyways, let's get into what, Chris touched upon, as well as some of the information that they sent. When we were in the bedroom there, Chris said, hey, 36 CFM. You can see that number there. Actually, it's, it's master bedroom, 24 and 12, so 36 there. Sorry, not that 36, but that 36. So that's the 36 that he was talking about. And basically what he was saying is that it's, 15 to 18 CFM per person is what they use as the calculator. So obviously there we're at that 18 number times 2, we get the 36. You can see also that they run through in the basement, even though nobody's living there. Remember, this house is fully conditioned. It's insulated. So the basement air is part of the in-house air, right? So anywhere we have in-house air, inside air, we want to make sure that we're exchanging that air. So even in the basement, we get this supply of 12 CFM. Then upstairs in the master owner suite, we get that 36. In the living room, we get another 36. And then you can see in the 2 bedrooms upstairs, they each get 24. So that totals out at 132 CFM that we're bringing into the building or supplying into the building, and we're bringing that in as good air. Now, these guys here strive to balance out those numbers. So in turn, the basement return we're dumping 12 CFM. So that's a pretty fair, even exchange there. You can see in the kitchen, we're doing a dump of 36 CFM, which is a direct relationship to the living room. Upstairs, we're taking out and exhausting 20 CFM, which is a direct exchange for one of the bedrooms. And then downstairs here, you can see when we were in the bathroom, we talked about, laundry mudroom, exhausting 12, the powder room, exhausting 24, and then the master bath, exhausting 24 there, right? And so those balance out that other 36 and that 36 there. So we end up with that 132 is bad air going out, and this 132 is good air coming in. So we get that nice balance effect. And, these guys just do a phenomenal job. They lay out, you can see there, all the CFM that's part of the supply, part of the return. They give us how many tubes are being there. If you remember in the master bedroom, we had 2 tubes and 1 tube there. That's what was getting us that 36 CFM. The registers, they lay that all out. The covers that they get, the location, whether it's in the ceiling. And next week, we're going to do part 2 with the Zehender, where we're actually going to take a look at the actual layout. And then over here, they talk about the control sensors in that bath 2, the master bath, and the powder room. Those all have that boost switch. And remember, we talked about that when we were standing in there, so that if you just took a shower, if you were needed some higher level of odor control in those environments, you basically hit that switch and it ramps up the system and puts it into basically a higher gear and takes out a little bit more air. So anyways, it also talks about average duct run, how many CFM per tube. They do a really, really good job. The fact that it's an ERV, the orientation of the unit, whether or not it had the preheat option, it's a wall-mounted system. So they do Zehender is a hell of a team that we get these spreadsheets and a whole bunch more information, but they fully lay out the system for you. You send them their floor plan, and then they give you all the feedback on how their system should be laid out. So it's a total collaborative effort. Remember, there is no substitute for team. We need teams. That's how we all get better, when we rely on each other to service their expertise and collaboration. One of my favorite words, right? I didn't think I could spell it that fast on there. But anyways, that's everything we need to know about the general concept of the Zehender ventilation system. So there you have it. Getting capped. Going to bed. Hopefully you enjoyed that. It's always great looking at some of the peripheral stuff that's happening in our buildings. That's not necessarily a construction detail, but a very required and a very important part of what we do. And like I said in the intro there, Chris Smith and the guys at Zehender, I can't thank them enough for being the teammates that they are and helping us out and getting this all done. So anyways, if you're looking for more, find me on Instagram at Stephen Basic Architect. You can also find some of our work under my daughter, Alexandra Basic, on Instagram. We're putting up stuff regularly and trying to get it out there and share it. And you know what they say, we're trying to lift all boats, right? And if you're looking for even further stuff, you can find me on the Unbuild It podcast. I team up with good friends Jake Bruton and Peter Yost. We have a lot of fun. This past week's episode was off the rails. We had a blast doing it, but we're also providing some really good information. So go check it out. Unbuild It podcast. It's on YouTube. Make sure you hit that subscribe button when you go there. And then lastly, you got the Build Show Network, right? You got my good buddies Wade, Jake, Brent, Matt, And then we have Mechanical Hub, Design Build Doug, Drywall Shorty, and Zach Detmore, all putting out great videos. Get tons of information there, so go check it out. Remember, science says 7 times. Make sure you watch mine before theirs. Anyways, but go check out those videos, and until next time, long live our buildings.